Good afternoon, everyone. Thank you for joining me today. Today's topic is all about fractions, decimals, and percents, and teaching strategies to get students interested, to help students in a multi-level class, and to give you some new ideas. Today's session is going to be a little bit low tech. All right, no worries, Kevin. It's low tech, just some basic examples that you can bring right to your classroom. Can you see my screen okay?
Yes.
All right. So I want to start by setting the stage. We're going to practice engaging multi-level learners in accessible fractions, decimal, and percent activities. So I'm going to use this teaching strategy here, this model. I'm going to start by giving you problems that will make students curious about the topic. I'll share some ways to teach conceptually. Then I will share some practice activities. Then I'll show you a way to make them more rigorous or to push the student critical thinking, push them more towards critical thinking. I want you to be able to keep your learners engaged, even those with limited English proficiency or learning differences. You will notice one thing today. I do not use algorithms to teach concepts around fractions, decimals, percents. So an algorithm is a rule, like a formula that you might use, right? So things that we say when we divide fractions, flip over the second one and cross multiply. I don't give rules like that. I go from the concept. And so you'll see today that I don't use those algorithms. And I think they're very helpful. Those algorithms might be helpful to the students that are GED ready or high school equivalency ready, but not when introducing these topics. The reason we go from concept first to algorithm and not the other way around is students need to know what these topics are before they can apply them, before they know when to use a rule. And so you see here, pique interest and curiosity. We're going to teach concepts, practice examples, and then talk about increasing the rigor. So let's start with fractions. We call this the F word of math because no one wants to deal with fractions, right? It's a hard subject for students to grasp. So let's start with a simple example. These are what we call fraction bars or fraction strips. This is a really easy way to start your students in a conceptual understanding of fractions. So either in the chat or you can take yourself off of microphone, you can turn off your mute. Why would you use this with students? What understandings might they get from this image? What do you think?
I would think to get a visual on the parts versus the whole.
Yes, that's a great comment. Part and whole. Helen says a visual seems easier to understand. Absolutely. In particular, those individuals that maybe they don't have experience with seeing fractions this way. Also, those individuals that fear math, it might be easier for them to see this with no numbers, right? And so this is all about the piquing interest in the topic. What other questions might you ask your students about these fraction bars? One question that I like to ask is how do they relate? Karen, welcome. I saw you pop in. Thank you for being here. We got some chat. Helen says students can see the relationship between part and whole. How many parts are in each whole? Karen says, thank you. So this activity is really all about comparing the fractions and looking for what we call equivalent fractions. Something that I might ask my students is, are there two or more that are the same? Right? So you see A, C, and E are exactly the same. And then introduce the word equivalent so that students can start to make those connections, right? So they're approximately the same length, right? And what does that mean? This one is partitioned into 4 pieces. This one's partitioned into 3 pieces. And this one has more, 6 pieces, I think. And so you see with this activity, you give students an idea of what fractions mean. Helen says, how many parts there are in each whole? Yes, absolutely. But at the same time, the whole is always the same, right? The one, right? Each bar is 1 bar. Really important fractions activity just to get students to understand that amounts can be represented in different ways using a fraction bar. Are there any questions around this? This is a really great activity for students that are fearful of fractions. So here's another activity. This is a number line, again, for that conceptual understanding. Notice and wonder allows students to think outside the box. They start to build an understanding. Even if they don't have the language to go with it, they begin to make connections with their own knowledge and experiences. So they may have seen a number line before, maybe used it as a tool to add and subtract, or maybe even have experience with counting yards in a football game, or using a thermometer or a ruler. They might have that experience. And so when I see this, I recall those experiences I have, right? Or those memories I've had around number lines. And now looking at the second line, I see that there is a number between 0 and 1. At this point, I'm asking again, what is between 0 and 1? I'm asking, what does that look like? And so your beginner students might have some time to think about that during a warm-up activity like this. And I will make sure you have all of these activities. Again, this is just one of those introductory activities you can do for conceptual understanding. That first one, you can see that it is divided in half. And students might say, oh, the top one's divided in half. Not really connecting half with the fraction 1/2 or 50%. And then when they see the other one, they're like, oh, what's half of 1, right? They can start to make those connections. Let's talk a little bit about another concept related activity. Stepping further into conceptual understanding, we look at these 2 representations of 1/2. I'm going to give you a moment to read the prompt. I'll read it aloud for accessibility purposes. Andre and Claire are talking about how to label fractions on the number line. Andre says 1/2 can be labeled like this. And there's a number line with the half written between 0 and 1, 0 and half, and as well as 0, the half mark, and the 1. And the other option says, Claire says half can be labeled like this, and they just have the half in the middle. How could each student's labeling make sense? So when you give students these familiar items like a number line, it's a whole lot easier for them to begin to visualize what the word half actually means. And 1/2 is one of those unit fractions that students need to be able to work with fluidly. Unit fractions are fractions that have 1/1 in the numerator and another number in the denominator, like 1/2, 1/3, 1/4, 1/5, and so on. So stepping further into this conceptual understanding, we look at these different representations. The students here are able to compare the two and decide what makes sense and what doesn't make sense, eventually coming to a conclusion that both of these scenarios can be true. So when you present this type of activity to your students, they get a really concrete understanding of what a half means. What thoughts do you have about this activity? What questions might you ask? And what might your students ask or respond to this? What might they respond to this activity? Hi, Carmen, welcome. What might your students say to this activity? Helen says they might say, but which example is more correct? That's a great question. Which example is more correct? Like, there has to be one that's the answer, right?
Yeah, I'm thinking like ABE students, they might say, but which one is correct or which one I should choose if I were on the math test, something like that. So it's like they want a definitive answer.
Right. They sure do want a definite answer. What if we changed the fractions in the first one so that it made more sense, right? So we can have the half between 0 and 1, right in the center. We've replaced the other half with 1/4 and 3/4, right? That gives the students a better understanding that we chopped this line into 4 sections. And the half that is written there represents the half between the first two like hash marks, right? These two marks. Oh, they might say it doesn't make sense to have half here and half here. And I know that this whole thing is cut in half here. But when we make an equivalent fraction, then they start to realize, oh, this is really about what's halfway between this and this. They start to learn about intervals, right? And doing things in a pattern, and they start to see the pattern. Again, this is an activity to help them further their understanding. Scenarios like this are really, really good for students to be able to start justifying their mathematical reasoning, which is a really important skill for adult students. Children will just take it and say, oh, okay, that's the answer. You said that's the answer, so it's the answer. Adult students, on the other hand, they need some reasoning behind it. And so you'll notice I talk a lot about reasoning and justifying solutions. So let's talk about this practice. Which one doesn't belong? This is what we call an instructional routine. You give the students a group of items that are related or somewhat related and think and give them one that doesn't belong, and let students reason out. So take a look at this and just put your answer in the chat box, A, B, C, or D. Which one doesn't belong? Karen says C. Carmen, how are you? What do you think, Carmen?
I'm thinking, so. A.
You're thinking
Oh, no,
A.
no, sorry. C.
C. Okay.
What
I
grade is this?
What grade is this? I'll tell you later.
Oh, it's adults.
It's adults, yes.
Okay, so
um,
B. C.
C. I got you. C. Why C? Why'd you choose
Because it
C?
looks like, it's me?
Yeah.
Okay, so there's two things going on. From a certain angle, because I have it up on the big screen, it looks like you're looking at 3D shapes.
Mm-hmm.
But if you just forget about that, but it's divided into fours when everything else is divided in halves.
Oh, I like that. I like that. You saw a pattern and identified it. Excellent. Did anybody have other reasons for choosing C? What other reasons did you have?
I may be wrong, but the way I looked at it, but now I'm having second thoughts. The way I first looked at it is that A, B, and D both are divided in half.
Yeah.
Whereas C is not divided in half. So maybe that's why. But then again, looking at A, it doesn't have a blue in it, whereas C has a blue in it. So there might be another way to say which one does not belong. So there may be two answers, probably. I'm not certain.
Yes. And so the point in doing this activity is to get those different answers, right? So students begin, excuse me. So students begin to identify patterns, like Carmen said, or to identify similarities and differences, like Carmen said. I'm sorry, like Helen said. This is a really good activity for students to start making connections to other topics. As we're talking about this activity, what practices or excuse me, what skills do you think students can demonstrate here? What are they learning by doing this activity?
Reasoning.
Reasoning. What
Critical
else?
Thinking.
Yeah, critical thinking.
Analysis, probably analyzing.
Analyzing. All of these skills, these higher order thinking skills that we want students to use on a regular basis, right? So that skill of analyzing is not just for math, it's for every subject, but it's also a great opportunity for students to practice making a justification for their answer. Let's take a look at increasing the rigor. So here's something that's a little bit more fun, but it also connects estimation with fractions, right? With relationships to fractions. What the problem says is estimation exploration. What fraction of the square is shaded? What fraction of the square is shaded? Underneath, I really love that it says record an estimate that is too low, about right, and too high. This forces our students to make a decision, right? It forces them to push their critical thinking as far as they can push it. And the same thing with the second example here. What fraction of the strip is shaded? What might be some of the methods that your students use to figure this out? What might your students do? David, how are you today? I haven't heard from you yet.
Fine, thank you. Hi, Maribel.
How are you? Oh, you're on mute.
For the first one, they might figure out that that could be divided into 8 parts. And the 5 of them are shaded.
How'd you come up with 8?
Because the diagonal is the diagonal of a square that is the upper left quadrant of the whole figure.
Yeah. That's a great answer. I think many of our students would try and figure out, how do I get a number that meets that requirement, right? Anybody else?
With the second one.
Yeah.
They could divide the bar in half
Mm-hmm.
and then divide each half in half,
Mm.
possibly more.
Sure. They could probably do any number, right? To get a rough estimate here.
Yeah.
It's a great opportunity for students to be able to divide fractions, right? This idea of, well, what do you mean divide fractions? So these activities really do focus on the conceptual understanding so that students analyze what a fraction really is. Once they figure out these types of activities, then you can tell them, oh, this is the process for finding equivalent fractions. And you give them an algorithm. But if you go back to here when we started, your students may not have been able to identify equivalent fractions until they saw this, or until they worked with a number line where they realized, oh, this is half, but it's also half if I show it this way, and that there are numbers less than 1. Any questions about some of these fraction problems before we jump into decimals?
Yeah, I have a question. I actually did just recently do a fraction unit with my students, and it was kind of a failure.
Mm.
And I did spend a lot of time with conceptual models. And I'm wondering if maybe I introduced the number representation too early. I mean, how long would you spend on that first type of activity?
On one of these?
Yeah, because my class is an hour and 15 to an hour and a half long.
Sure.
And to spend that whole time with shapes like this, it seems like it becomes really repetitive.
So that's a good question. Do you spend the time, and this is a rhetorical question, not really a question for you, but does one spend the time getting that foundational knowledge and then give them the algorithm? Or do we jump right into, this is the rule and this is the circumstance that you use the rule for? I think it really depends on the student, how much time you want to spend on this. When you do an activity like this, for your students that are really struggling, no numbers. Just get them used to cutting out paper and folding it in half, or folding it in fourths, or whatever it is. For your students that are more advanced, and you'll see I come back to fraction bars later on, you can do all kinds of calculations with this. And I'm going to share at the end of the session, the resource that I get all of these problems with. Some of these come from early grades, like 3rd grade. I know with adults, we don't often use those equivalents, the grade level equivalents, but just for understanding where the levels start with these activities, this is about a 3rd grade. And you'll see as we get more complicated and push into decimals and percents that you can make it more challenging for those other students. Maybe they're cutting out fraction strips and doing other, using different values, like a fourth plus a half is 75%, and doing other calculations. I think at the end of the day, they need to have some conceptual understanding before they move on to memorizing the formulas. What do other people think? What do you think? What advice might you share with Karen?
This is Cindy. Can you hear me?
Yes.
Hopefully the baby won't holler out. What I tend to do when it comes to what I feel it will be a more complex type of math like fractions, and I've done this with linear equations as well. We do the conceptual piece, but I also ask my students to think about where have they used fractions without them really ever knowing that they actually use the fractions. So I have a lot of students that even when they don't remember, I give them realistic examples, like take an apple and cut it in fours,
Mm,
or take your dollar, split it into dimes to give you that dollar. So this way, because I'm attaching something that we use every day to the fractions, they're like, oh, okay. Some seem to get it that way as well.
yes.
I try to use different tools, especially things that they have touched and felt before, to grasp that we've always used fractions. We just never really realized it, or even ratios.
Yeah.
That's another one that I know some learners are like, well, how can I tell the difference between the fraction and ratio? So to be honest, there's really no difference. They're
Yeah,
one and
there's
the
not
same.
much.
Right. It's just how we apply
Right.
it.
I think those are great suggestions. I just held up a ruler. You probably can't see it too well, but how many of our students have had experience with a ruler and how many haven't? You can go to IKEA and get those yardsticks and have them do a lot of activities. At the end of the day, I think it really just depends on whether or not your students are ready to jump into like a GED workbook, right? They need some primers, they need some support. The activities that I shared today are just a sampling of ways that you could introduce fractions so they start to get that conceptual understanding. Karen, I want to come back to your question, but I want you to see how we apply this in decimals. Oops, which way am I going? All right. So we're going to come back to Karen's question. I want you all to think about that. In the next couple of problems, I want you to think about what your students would see when they see this problem. Again, starting with the idea of introducing values less than 1. We're going to start with understanding that this grid or this square is a unit, right? It equals to 1. So 1 by 1. And it is divided into bars. They begin to develop an understanding that this blue bar is less than 1. It is a part of 1. And that goes back to what Helen said in the beginning about part and whole, right? They realize that this is a part of a whole unit. This activity says, what does the shaded region represent? So again, it doesn't ask for a number. It just says, what does it represent? This is where students will connect. Oh, I learned about fractions. How many little pieces are there? Okay, this is 1/10 of 1. And then they start thinking, what does that actually mean? 1/10 of 1. We push them further. In this example, again, they realize that those tenths from the previous image can be divided even smaller. And that those tenths are divided into 10 pieces each. And now we have hundredths, right? They might do a multiplication problem, 10 by 10, and realize, well, 10 by 10 is 100, but you're saying that this is 1 inch by 1 inch or whatever the unit is. This is to get them to realize that we can divide 1 or we can go less than 1. And it connects right back to those fractions. right? And it brings me to Karen's question about how to get them to understand what fractions are when maybe those images are not really rigorous enough to get them to understand, or if, throwing math problems on the board is not enough to get them to understand, connecting it to decimals. And that's what fractions, decimals, and percents are all about, right? Connecting the dots and making different ways to represent numbers, less than one whole and greater than one whole, but for this portion, less than one whole. What are your thoughts on this activity? What would students learn from this activity? I see you, Carmen. What do you think? Carmen's gonna run away. Go ahead, Karen, go ahead.
Sorry.
I'm on mute, I'm on mute. Do I say what I want them to do, or what I hope that they understand that's like a penny. That would be like a penny.
Tell me
and
more.
Grid would be $1. And
Yes.
if I had 1 penny, it would be representing 1 box. And that
Yes.
would be 0.01. I would like to know that, because I'm the greatest teacher alive. Magically understand that. It only took me 20 years to understand that.
Only, right? I think when we teach math, it reminds us of the things that we didn't remember, or things that we kind of take for granted. Like Cindy said, she wants her teaching to be meaningful to her students by connecting it to something they already know, right? And so Carmen said 1 cent, bam. What does cent mean? What does that root mean? It means 100. In Spanish, 100 is 100, right? Centavo is 1 cent. So making connections, building the connections is so important. Karen, you were going to say something?
I was basically before I had my coughing fit, I'm gonna say basically the same thing that Carmen said as well. I mean, I find that using money is a really good way to start talking about decimals.
Absolutely. Absolutely. So let's push them a little bit further now. Balancing weight. So this print is really small. I apologize. I will make sure that you get the slides as well as the resources that these images came from. Now they're going to apply what they know to make equivalent amounts, right? The balance beam. We use the balance beam a lot in algebra, but it works for other scenarios, right? For each problem here, you have a balance and a weight and weights of 1/10, 100th, and 1/1000th of an ounce. A gold nugget weighs 0.2 ounces. What is one set of weights you could use to balance the nugget? Explain or show your reasoning. Now, this starts our students in a different, it starts them on a different path. What skills would they learn from doing this activity? Najima, I haven't heard from you. Are you there?
I'm here, and
Wonderful.
it's Jemay. That was a great effort, but it's Jemay. The N is silent, so it's just
Okay, Jamea.
Yeah,
Wonderful.
you said, so what skills would they be delving into?
Yes.
Once I'm asking them to balance the two sides.
Yes.
Well, equivalencies is one.
Yes.
And realizing by looking at the balance that there is a way to create equivalencies between decimals and fractions of varying sizes.
Yes. Yes. And that you could have, I'm going to use a much simpler example, 3 oranges that equal the same as 4 apples, right? Just purely on what the weight is or the value of each of those amounts, right?
Right.
Yeah, great. Equivalence and balance and making numbers match, right? Trying to figure out what will make this balanced. Such an important skill. Also, working through place value here becomes a huge kind of underlying concept that students have to figure out with this, right? And so in the previous example, we start thinking about place value and we start building that foundation. And now they have to use it for an even more complex problem. Again, we're building on previous examples to push it to the next highest level, push the rigor of these examples. And so it says for B and C, different questions. What is another set of weights you could use to balance the nuggets? And C says, how many 0.01 ounce weights would you need to balance the nuggets? So they give you an example to use. A really great activity just to get people talking. Here's a practice activity that I would give students. True or false is a very low stakes activity. Students are not afraid to say true or false because they don't have to justify it out loud, right? It gives them an opportunity to think about why I know this is correct or not correct. Again, once you have that foundation in place value, they're able to use these activities to determine how to do operations with decimals. I like to always teach students to put zeros at the end so that they can line them up. And line them up is not a technical term, but I think we all do it when teaching decimals and place value. You have to line up those decimals so students can see that a number can keep going with zeros. It doesn't change the value. And again, an opportunity for students to explain reasoning. We increase the rigor here, then you can see how we're using properties to reason about multiplication, right? Excuse me. Elena and Noah use different methods to compute 23/100ths times 1 5/10. Both calculations were correct. And this is, I'm just gonna, as a sidebar, when you give students 2 different methods, they ultimately make connections with one of those methods and they start to take ownership. But knowing that there's different ways to answer problems is a really powerful moment for students so that they feel that their method is not necessarily wrong, even though the teacher explains or the example explains something differently. Because there's a plethora of ways to answer questions. And so validating that really does help students feel positive. So here we have 2 examples. In the first example, Elena multiplied 0.23 times 100 to make it a whole number, right? And goes through the problem, then divides it by 1,000 so that she could put the decimal back in the problem. And then the other person does something really awesome. They made it a fraction. This is the method I like. They made it a fraction. So much easier to work with once you're familiar with thousandths as a fraction, as a denominator. The question asks students, analyze the 2 methods, then discuss these questions. Which methods make more sense to you and why? And so this gives our students the opportunity to communicate about math, to think critically. Something I would do for English language learners is give them time a lot of time to jot down their answer first, to write down the words that they want to use. Give them access to a dictionary or a picture dictionary or a math textbook so they can look it up, look up the language they want to use, or start with sentence frames. But this gives the students an opportunity to break down someone else's work with, and it's very low stakes. People often have math anxiety. And so when it's not their work, it's a whole lot easier to break it apart, right? And the last question says, compute each product using the equation 21 times 47 equals 987, and what you know about fractions, decimals, and place value. Explain your reasoning. Again, a really important question, explain your reasoning or show your reasoning. Students don't necessarily have to write down the fractions, right? They could use a picture. I have tons of manipulatives and options for students to, draw pictures. I always let them draw pictures. Helen says, for me, I like more the second method. Noah, it looks more visual to me and easier to understand. Exactly. And for other people, they may really enjoy doing decimals and will do it that way. So I think knowing that you can transfer between decimals and percents and fractions is a really good skill for students to have. Any other thoughts about decimals and teaching decimals? All right,
Okay, I have a question.
go ahead.
So when you talk about hundreds and hundredths,
Yes.
I just remember sitting in the classroom in like the 3rd or 4th grade, 5th, Miss Brathwaite, she kept saying hundredths, hundredths. And I'm like, why does she keep saying it like that? And years later, I was like, oh. But one thing that really, and I wonder if any teachers do this, understanding the place of understanding how zero works.
Yes.
In decimals, that when you add them one way, it doesn't change the number, and when you add them another way, it does. So that really helps solidify my understanding of less than 1.
Yes.
And getting gas and seeing that number go up. When my son was in the car, I remember showing him how you could see 0.9 and then it goes to 1.0, and it was just, so the manipulatives help, but also I like the virtual manipulatives as well.
Yes, I love virtual manipulatives, but also you can just tell them, make a square, cut it into 10 pieces. It doesn't have to be exactly 100%, but you can see each of those is less than the whole picture. And if we cut each 10th into 10 pieces, oh, look, now we have hundredths. And then you just tell them, we changed the name of it to reflect that it's on the right side of the decimal, right? But I think that's really important, is sharing the lingo that we use and the language that we use for decimals and in place value, and how important it is. You know what, I always bring out a fake check, right? I either draw it on the board or I'll pull up a sample check, and I'll say, take a look at this. If I pay my bill 45.50, right? $45.50, that's okay. But if I put the decimal point in the wrong place, I'm paying $450, right? And so automatically they start laughing. They're like, oh yeah, I wouldn't want to do that. But it automatically makes that connection to something real and valid, right? Oh, if I put the decimal point in the wrong place, I'm going to be in trouble. Helen says, I like making connections with decimal and fractions and also examples from real life. This makes it more authentic and the concept can be better understood and retained. Absolutely. Let's talk a little bit about percentages. Oh, the money comes back. The money comes back. I really like using money because clearly everyone can relate. Well, with American money, at least. This first number line always gives students pause because they know there's more than one, but they're not always sure what it means to be less than one. And then percentages, here we're asking the coins in Jada's pocket are worth 75% of a dollar. How much are they worth in dollars? That's a little tricky of a way to explain it, right? What percent of a dollar are these? And so again, go back to that image of the 100 grid and explain if you had more than one of those grids and only half of it was colored or colored in, that would be 100 plus 50%. Or 150, $1.50. It's all about making the connections here. Again, not sharing any algorithms, but this is a way that students can start to see 100% be a reasonable number. Like it makes sense to them to see, oh, if I hit $1, that's 100%. I've made the whole amount towards that $1, or I've got 100 pennies. But if I have more than 100 pennies, clearly that percentage goes up. So what I also like to bring up is the fact that decimals, or rather a coin, a dollar coin, is the same as a dollar bill, right? So fractions and decimals are the coin and the dollar bill. They're the same amount, just represented in a different way. So just something I like to throw in there. Excuse me. Here's another example. Fill in the blank. The value of 8 dimes is blank percent of the value of a dollar. And then another one, name a combination of coins that is 130% of the value of a dollar. Again, conceptual understanding so that they understand what more than 100% means, right? Usually we see in the GED books or the high school equivalency material, it says this t-shirt is sold at $54. It's 50% off. What is the value of the shirt? Or how much does the shirt cost? It's very typical. But when you see my rent was raised 120%, that's a totally different thing. And they're like, what do you mean 120%? That's a whole different concept, right? And so when you do activities like this, it gives the foundation to push them further in understanding. Take a look at this activity. This kind of starts to bring everything together. Again, we talked about those fraction bars, right? This is liters, meters, and hours. Number 1 says, how much is 50% of 10 liters of milk? And the student would need to pick one of these images that matches that question. It starts off simple. And then the second set of problems is for them to draw a picture that would work, or draw what we call a model that would work for those problems. It's something that is a little bit of a different take on understanding what decimals and percentages are, but it helps students to visualize. And when you can draw a picture to help you understand what's going on, you are that much more ready to complete the activity. And pushing further to increase the rigor, 9 is 50% of what number? And again, this image makes it super clear. They're deepening understanding. They're demonstrating the concept of whole and part, using fractions, using a numerical value. This is a hugely popular activity for explaining part and whole. I'm going to take a moment to ask if you have any questions so far. Comments. Okay. And this one is, again, matching the percentage. This match the percentage that describes the relationship between each pair of numbers. 1% will be, 1% will be left over. Be prepared to explain your reasoning. Always getting students to think critically. 7 is what percent of 14, right? Easy. 50%. Oh, what's the relationship? Students are constantly looking for relationships with numbers, and we have to continue to push that for them so that they have a critical eye for patterns, right? They see, oh, 7 is half of 14. Another way to say that is 50%. They start building those connections, and the only way we learn is by connecting new learning to the old learning that we have in our minds, right? The stores of knowledge. What are your thoughts? We have a few minutes left for the presentation. What are your thoughts? Are these tasks something you can do with your students? And what would be the value of taking a more conceptual approach with teaching these skills?
I don't want to cut people off. Did anyone else have their hand up? This is
No.
Carmen.
Go ahead, Carmen. You can go.
I've noticed that I haven't taught adults at this level like all day. Like before, it's like a class. You don't get to see them that often. You know what I mean? It's
Yeah.
just, I have a lady that comes almost every day. And what happens is as we talk, I notice that they remember, they say, oh, I helped my grandchild with this, or I helped or I remember this in school, or, you know, I had a lady, she was cussing me out on the way out about she couldn't do this, the XY axis.
Oh boy,
Got home
yeah.
on IXL, she's like, I did it. I said, what? You know, and I'm sitting there like, wow, how did you miss the XY axis, you know?
Yeah,
Then I had one learner, she knew the whole thing. She knew which way to go, which quadrant. And then, you know, it's just filling the gaps. And I think the
yes.
talking part, rather than like just passing out a worksheet, talking about it, you get to, because with adults, there's a lot of
anxiety. And I think you are 100% right, Carmen. The opportunity to reason and think it out is the critical moment for understanding. When they can explain it or their methods to their colleagues or their peers, it is that's where they understand. That's the sweet spot, if you will. Anyone else? Cindy, how you doing over there?
I finally got this baby to sleep.
Oh, that's how boring I was, right?
No, she was rocking my world. She was like, girlfriend, take a nap. No, I think when it comes to like the anxiety, speaking about anxiety with my learners, I always try to promote myself as their biggest cheerleader, only because I've noticed with some adult learners, they don't have that support at home. And
Sure,
it's so important to have that. So I let them know I'm your support. So
that's right.
I think because I promote myself as their biggest cheerleader, whenever we have some learners that have anxiety of not wanting to answer a question, my biggest phrase, and they'll tell me, is like, I got you. I'm here, I got you.
That's
Even though
it.
we're on remote, even though we're Zoom, I got you. So let's walk this through. And then I'll make sure that, you know, sometimes you have to. I think
Yeah,
that's the project management in me, where sometimes you have to hold the hand
that's
just
right.
to help them with that confidence to get over that little gap and bridge that they're experiencing.
Excellent. That's it. You know, we have to cheerlead for our students because they already took a huge jump, a huge leap of faith walking into your classroom, right? So many of our students, they're like, oh, I haven't been back to class for so long. We have to be their cheerleaders. And if we can give them foundational information so that they can apply it to other situations, either to their lives or to something that they do or help their children or grandchildren. It helps them feel like they're accomplishing that. Kevin says, I really like asking students to draw a picture worth 1,000 words. Yes, that's it. It is. Asking students to draw pictures, oops, sorry, to help them is incredibly powerful. This right here, I use this all the time. It's so easy for them to understand, oh, I need to figure out this number and I need to figure out this number. What's the percentage here? Great, great response. We are almost out of time. Please feel free to email me at any moment. You can reach out to me through my website. I'm on social media. All of these examples today come from this website. This is the internet's best kept secret. Hold on, let me pull it up for you. This is a math curriculum. Yes, it is K-12, but it is so useful and it's free. I'm going to put the link in the chat. It's a math curriculum that is leveled and aligned to standards. I put the link in the chat for you. Save it. Save it, save it, save it. You just hit launch curriculum. They have the families. So those students that maybe are working with their younger kids. They also have en español. They have the teacher materials. They tell you about the materials and how to use it, assessments. They have all kinds of things. And Helen, look, they have math language development and access for English learners. They have universal design for learning for students with disabilities. Great materials, great materials.
Yeah, I bookmarked the link. Thank you for sharing. I will check it out.
Yeah, and we have this on our website, the PA Adult Ed Resources page
Oh,
too.
great. Yeah.
That's the math curriculum. Okay, so I
Thank
do
you.
want anytime, and I do want to let everyone know that the previous webinar that was canceled, tips for lesson planning, will happen on Thursday, May 25th at 2:30. We'll make sure you have that link. Also, there's another session that is happening next week. Let me just double check the name. Next week is graphs, teaching graphs and data using authentic materials. So we'll look at using newspapers and magazine articles and other pieces of authentic material to teach data analysis and graphs to our students. I hope this was helpful. Please fill out your evaluation form that will be emailed to you. We will also send you the recording. I really appreciate your participation and I look forward to seeing you all again at our next session. Take care, everyone.
Thanks, Maribel.
Thank
See you
you.
next time.
The same, thank you.
Thank you. Take care, everyone.